Okay, here we go. 4.5, section 4.5. We're going to talk graphing other trigonometric functions. So we've been talking a lot about sine and cosine and those functions. Well, the other ones have graphs too, and so we'll talk about those. So buckle up, just so you know, because it's going to be interesting. Okay, so the big thing to think about here is that just kind of want to mention this, that tangent, if you remember, is sine over cosine, sine of x over cosine of x. So there are some things that we can show with the graph to see why it looks the way it does. But here is the graph, what it looks like, and here are the properties of it. And so you can kind of fill these out as you go. I'm going to try to go through because there's a lot to it. So I'm going to try to go fast here, and then you can pause, rewind, do what you need to do. But your domain here for x is all reals, but just understand that it can't be pi over 2 plus n times pi. Basically, what that means is odd multiples of pi. Essentially, that's what that means here, is that odd multiples of pi is where we can't have it, so we'll have an asymptote there, basically. Okay, the range, we can see the range here is all reals basically as well, negative infinity to positive infinity. Your x-intercepts, so then again, this is n times pi multiples, as long as they exist within the set. And again, that, so we're talking, just so we know, is that this n times pi just basically means multiples of pi. So 1 pi, 2 pi, 3 pi. Where up here, odd multiples of pi would be your 1, 3, I'm sorry, this would be pi over 2. Make sure you make that change. Odd multiples of pi over 2 for the domain. So that would be like pi over 2, 3 times pi over 2, 5 times pi over 2, and so on and so forth. Okay, and this is the tangent function, this is the parent function tangent. Okay, where your x-intercepts are going to be multiple intervals of pi. So you can kind of see that over to the right. We'll show you that in a second. The x-intercept is 0, or sorry, the y-intercept is 0. It's only going to cross once, and that's at the origin there. And then you can see the continuity there. And the other thing we're going to focus on here with all this other stuff is the asymptotes. Okay, we'll talk about that. But that's going to be pi over 2 plus those multiples of pi. Okay, and times pi. So again, what does this all mean over here on the right-hand side? So we can take a look. First of all, let's just point out we have a period that is pi. Okay, and it's pi because of how often it repeats and does certain things. So again, we just want to make sure that we kind of just get the idea that the period is pi length. So for instance, here you can see, just pointing out like those domain, we can't have, it can't be every half pi. So you can see right here at like half pi, we've got a vertical asymptote because it won't work there. And same thing, multiples of that. So 3/2 pi would also have 1, and then like -1, odd multiples, right? So odd multiples of pi over 2. So negative pi over 2 would also have a vertical asymptote. And so then the graph kind of works its way by going on this little squiggly line, but passing through certain points. Okay, and it passes through the x-intercepts here at multiples of pi, so pi, and then there would be one over here technically, 2 pi, 0, and then negative pi, and there would be one over here if we continued it. Okay, so just kind of pointing those things out. Now the asymptotes are there for a reason, because like we mentioned, and you don't have to write this part down or put anything in here, but just want to throw this out there that remember what we talked about was that this is, and I won't say this for every function, but just kind of get an idea how it works. But remember, the tangent of x is equal to the sine of x over cosine of x. So when we know that cosine is 0, we know it's undefined. If cosine here was 0, we would be undefined. So where are the values in which cosine is 0? Well, that would be right here, here, and here. So that's why we can't have a value there, okay? The other thing to point out here is that and again, just to show that, to illustrate it, and again, if I use, let's say I put the cosine graph in here. Like I said, you don't have to draw this, but if I put the cosine graph in here, what you would see is that it would kind of go down through here, and then it'd come back up through here, and then come back down through here, and up through here. So these points is where cosine is at 0. So if I put 0 in here, well, then it would be undefined because you can't have 0 in the denominator. So that's why we need those asymptotes for tangent, okay? And then really all of them have those as well. Now the sine values as well. So what about when sine is 0? If sine is 0, then we have different zeros. So if I put the sine graph in here, think about where sine is 0. Sine is 0 right here, and it would come back down and be right there, and it would come back up and be right here, and then kind of work its way down and keep going. But look at where those values are. They're here. So we would have zeros. Tangent of x would also equal 0 when the sine is 0. So that's why we have points on the x-axis when that happens. So that's why we have this graph that looks like it does here, where we have these different lines that are not continuous. You can see the continuities right here. It has infinite discontinuity, but you can see how we have to cross the axis here because that's where sine would be 0. But then as we move up, we end up getting closer and closer to 0. And we move down, we get closer and closer, but we don't necessarily have a value, get closer to the infinities, okay? So that's why we have that type of graph for tangent, okay? So let's continue. The period of the tangent function. So I made a point that it was pi. So the period here, we can say, we can find out that it is right here. It is pi over your b value. So in our parent function, the b value is 1. So that's why our period here was 1, because the b value in the parent function is 1. So it's going to be pi over the absolute value of b if you have a b value here. Okay, and our period is just between the asymptotes. That's what we're looking for, between any two consecutive asymptotes. So when we graph this, we're going to have to find those consecutive asymptotes. And how do we do that? We do that with solving these equations. Okay, bx plus c equals negative pi over 2, and bx plus c equals pi over 2. Let's solve those equations. Remember, you've got these things, b, and you've got your c right there that you would have to find them from that equation, from the tangent function. Now, where do we get these values from? Well, that just goes from up here where we talked about how we have these odd multiples of pi over 2 that we have our asymptotes. That's how we got those, okay? So when we graph these, what are we looking to do? So if we're graphing a tangent function, we've got to plot our vertical asymptotes, and we can get that by right up here with these two equations. They'll give us consecutive ones. Then we can look and find our x-intercepts, and then we want to get points between the vertical asymptotes and the x-intercepts, and that's kind of how we get our curve the way it is. So let's do that. Let's do some examples here. All right. So let's first take a look at what we have. So the first thing we want to do is we've got our function here of x equals tangent of pi over 2. So remember, our b value here is actually going to be 1/2 because you have, your b value, we have 1/2 pi basically. So when we talk about our period, because we actually have a b value in the parent function, we didn't have one, right? It was b value was 1, but here we have something. So remember, it's going to be our period is pi But because we're going to divide that by our b value of 1/2, we're going to actually have pi times 2 or 2 pi. So our period here of this one is actually going to be 2 pi instead of pi. Okay, so our asymptotes. Let's look at our asymptotes. So that's the next thing we're going to have to look at. Okay, so remember, we have to solve those equations from above that we had. Bx plus c equals negative 1/2. Or negative 1/2 pi, or pi over 2. And also, you'd have to do bx plus c equals pi over 2. Okay, so when we do that, what we're looking at here is we have our b value is x over 2. Now, there is no c value because we don't have the parentheses, so it's just simply 0 equals negative pi over 2. And then here on this other side, we've got x over 2 plus 0 equals pi over 2. So essentially what we're doing here is if we multiply by 2 on each side, you're going to get x equals negative pi, because these would cancel out, right? And over here, you're going to get same thing. If I multiply by 2 on each side, right, cancel x, cancel, you're going to get pi. So my asymptotes are at negative pi and positive pi. So what that tells me is what I can do is I can go and say I have an asymptote at negative pi, vertical asymptote here, and I have one at positive pi. Those are consecutive asymptotes. Okay, and what that tells me, if you take a look just at the period here, we're going from 1 pi, here's 1 pi, here's the 2 pi, so we've got our period set right there as well. So we should be all set to go. Now, because it graphs how it goes, what we can do here, we know it's just your normal tangent function, so I know I have a 0 here, and so I'm going to plot my x-intercepts, which is right here, and that's going to be that distance kind of right between them, so it's going to kind of go swoop up like that way, and then come back down here like that. You're also going to have a couple at these points here. Now, you can use a graphing calculator for this as well, or you can use Desmos, but you're going to have some other asymptotes as well. But I probably should have changed the x-axis here as well, but it's going to kind of look like this also. And you would have like another vertical asymptote over here, and you'd have one over here. Okay, I probably should have condensed the x-axis a little bit so that you could see those other asymptotes, but that's kind of what we're looking at there. And again, just pointing out here that the distance between here and here is 2 pi, as that's one period, okay? Just some other things to think about, just to make a note of it. Remember, you could use a graphing calculator or Desmos or something like that. To do this, when we graph sine and cosine, I kind of like us to figure it out on our own, but with this, it's okay to do that. Just make sure that you're in radian mode if you do that. I think most of them are if you've been using them, but just check that. And when you go into the window, if it doesn't work out, look at going like zoom 7, and that'll be your like trig functions that'll help you. Zoom 7 and trig, and it should help you get the graph. Okay, let's take a look at another one here. Okay, so we've got a couple different things to think about. So if I'm looking at my period first, my period is going to be, I don't have a b value. My b value is 1 right in front of the x. So since my period is pi over 1, I know my period is going to be pi, right? And then when I look at the asymptotes, again, I'm going to look at x minus 3 over 2 pi equals negative pi over 2. And again, it's 1x because I don't have a b, right? And then the second one would be x minus 3 over 2 pi equals pi over 2. Now, where am I getting the x? Is because it's bx, right? I don't have a b. My b value is 1. And then it's plus or minus c, or plus your c value here, right? Which is, in that case, a negative 3 over 2 pi, okay? So that's how I'm getting these values there. And solving for those, you can solve them, but what you're going to get is x equals pi, and then x equals 2 pi would be your asymptotes. So when I do that, I know at pi, I've got an asymptote here. So these will give you consecutive asymptotes. Boom, boom. And this one would be here as well. Okay. So that means that every pi, you're going to have an asymptote. So there would also be one at the y-axis. There would be one at negative pi as well. And there would be one here at negative 2 pi. Because remember, we have a period that is pi length. So again, just looking at the distance between these two is pi, right? Now, the other thing to point out here is that this graph, we graph our zeros. Again, we don't have any vertical shifts, so I know that it's going to go through here, 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 and here, because that's where tangent is going to be 0. And then when we do that, the only thing we have to think about is this right here, that negative sign is actually going to reflect it over the x-axis. So what that's going to do is kind of change the direction. So these kind of increase from left to right. So now this one's going to kind of decrease from left to right. So these will kind of start up here and work its way down like that. Okay, and there you have it. All right, let's continue on. So we move on to cotangent. So cotangent is going to be just the opposite. We had that. You can see that there's a lot of the similarities between tangents. So I'm just going to kind of highlight the things that you should write down. Again, same thing with our domain. Our range is the same as the tangent. Our intercepts are similar. There is no y-intercept here because it's not going to cross the y-axis. The y-axis is probably going to be an asymptote on the parent function. Okay. Notice that there is infinite discontinuity. The asymptotes will be here as well, and our period again is 1 pi for the parent function. Okay, so a couple things to point out here again is this first one here, when you're looking at x-intercepts, these are going to be odd multiples of pi over 2 again. So very similar. You can see the graph is just kind of flipped, almost like a reflection of the x-axis. And then the asymptotes are going to be multiples of pi. Okay, just kind of have the information down. All right, same thing here with trying to find 2 consecutive vertical asymptotes. But when we do that, what we're looking at is right here, and right here are those equations. So we've seen that bx plus c equals, but in this time, instead of the tangent one, when we're dealing with cotangent, you're looking at bx plus c equals 0 and pi instead of negative pi over 2 and pi over 2. Okay, so it's slightly different on the equation if it's a cotangent. All right, so let's work through those and let's talk about cosecant and secant as well. So cosecant and secant, you can see these have really weird looking graphs as well. But when you kind of just take a peek at it, when you see that you've got the right here is the sine function, and cosecant is the reciprocal of sine, right? So when we do that, you can see here's the sine function on the dotted line, and I just drew it in red, that when we flip those, we've got to have a parabola on each side in between those asymptotes that has a maximum or minimum at each maximum or minimum point of the sine. Same thing over here with secant. Secant is the the reciprocal of cosine. So if you look at the cosine graph here, okay, then you can see how the secant graph is going to work based on cosine being maximum, minimums, kind of touching there. Okay, so we have asymptotes, just to point out, on cosecant, we have asymptotes where sine of x equals 0. And then we have also, and occurs at integer multiples of pi. And then secant, we have asymptotes at cosine x equals 0, which occurs at odd multiples of pi over 2. You can see that in the graph up here, and where the asymptotes fall right here at multiples of pi, and then over here at multiples of pi over 2. Okay, just kind of showing that. All right. So some other properties, and you can again pause and rewind and do whatever you need to write these down. But our domain is here. You're going to need that. The range you can see is a little bit different. It goes to -1 and +1. There are no x and y intercepts because you can see y +1 and -1 because that's where the cosine and sine graphs stop, right? That's their maximum and minimum points. Okay, so we have a different type of range there. You don't have any numbers between 1 and the -1 with the parent function. Again, no x-intercepts, no y-intercepts for cosecant, but secant has 1 there. And then when we keep going, we can look at the continuity, and then your asymptotes here, right there, are kind of denoted by that stuff there. And we can find those below. But just like sine and cosine here, our period, just want to point out, is the same. It's 2 pi. It's not like tangent and cotangent where their period is only pi. Their period is 2 pi. So I want to point those out as well. And you can see how the graphs kind of look and what they look like. Okay. You can see right here also that this does have a y-intercept because this one will actually cross the axis right here where cosecant does not. Okay. So you can pause, rewind, do all the things you need to do on that. But just to point out, to find 2 consecutive vertical asymptotes, solve the 2 equations. Bx plus c again, that's going to be the key, right? That's the key to all of them. But what are they equal to? For secant, it's negative pi over 2 and 3 pi over 2. And where do those come from? Those come from those multiples, those pi multiples, those negative multiples of pi, and odd multiples of pi, things like that. So, oh, I didn't write that down. That's why. Okay, so up here with the, just to point it out, for the domain in cosecant, we're talking again multiples of pi. And in secant, we're talking odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, et cetera, et cetera. That's why when we're talking about secant, these are these odd multiples of pi over 2. Whereas in cosecant, again, it's the same equation, bx plus c, but now, because like we talked about here, multiples of pi, now we can set it equal to negative pi and set it equal to positive pi to find our vertical asymptotes for cosecant. So you got to know what function we're dealing with, and then we can do that. To graph the cosecant, to find the asymptotes, and then find the corresponding maximum and minimum points. Corresponding maximum and minimum points. So let's graph one of these, and then we'll do one where we solve an equation, and then we'll be done. All right, so here's our graph. F of x equals cosecant 2 theta minus pi over 2. So let's find our period, okay? So our period is 2 pi over our absolute value of b, right? Well, our b value here is 2, okay? So, because we know our period generally is 2 pi, but if we have a b value, it changes that. So now we go 2 pi over 2, because that's my b value. So my period here on this function will actually be pi. Something to keep in mind over here, and I'll write that in a second. Let's get our phase shift, okay? So our phase shift, remember, because we do have one, because we have this c value here, we have a phase shift. And so if we remember, that's negative c over the absolute value of b, okay? And we know that is equal to, we've got our c value is pi over 2, or negative pi over 2, so the opposite of that would be pi over 2 over 2. So when we, divide by 2 or multiply by 1/2, essentially that's what we're doing, you're going to get pi over 4 for the phase shift. And we know we also have a vertical shift right here of 1. So we're going to move to the right pi over 4. We're also going to move up 1 as well. Okay, now I did say that we're going to point something out over here, and so I'll do that. That right here, it's a period of 5, but we got to think that we have 2 halves that we have to draw, right, on the graph. You've got, one parabola that's going up and the other one's going down. So we have to kind of do that. So we have 2 halves need to fit within pi, because that's our period, within pi. So one thing you might want to do is cut in half for your vertical asymptotes. Okay? Now, you can cut them in half, that's one way, but also if we want to find using the above formulas that we talked about for cosecant, right? Cosecant is here. So if we do that, if we use these formulas here to find our vertical asymptotes, what we'll end up doing is we'll get 2x minus pi over 2, that's my bx plus c, equals negative pi. And the other one is 2x minus pi over 2, bx plus c, right, equals positive pi. And when we solve that, essentially, again, what I'm doing is I'm going to multiply so if I add a pi here, I'm going to have 2x equals negative pi over 2, right? When I add pi over 2 here. And then I can multiply by 1/2 on both sides, just kind of showing that really quick. And we're going to end up getting x equals negative pi over 4. On the other side, again, basically what I'm doing, I'm adding the pi over 2 to the other side. So, right, add pi over 2, add pi over 2. Got to skip that step on the last one. So you have 2x equals pi plus pi over 2 is 3 over 2 pi. And then again, multiplying by 1/2 or dividing by 2, right, gives me x equals 3/4 pi. So these are my vertical asymptotes. So when I do this one, I kind of have to draw them in there, right? I've got negative pi over 4, which is going to go like over here. Because if this is negative pi, this would be negative half pi, so negative pi over 4. And then this one, 3/4 pi, is going to go right here. Or would be that one, okay? So those would be my asymptotes. Now, There would then be one every section like that. So as we continue on with graphing this, so that kind of gets us started. But to graph it, I think the easiest way is to kind of use that, the reciprocal one, the sine, right? So the sine function, remember, we've got a vertical shift and a phase shift of pi over 4. So our vertical shift means that we're going to go up one. And so we're going to have a midline that's going through 1, because usually the midline is 0 as the x-axis. But because this vertical shift here, it's going to move it up 1. And we usually start at 0, 0, but we're going to start at pi over 4 because we're shifting to this part here. So our starting point is actually going to be right here for the sine graph. And it's just going to kind of go up here. Oops, I should just back that up a little bit because I know that I have an asymptote there. So when I do that, we're going to have kind of our graph look like this, going up, then turning back right here, coming back through, and turning at pi, right? And then moving back up here. Okay, right? And then kind of keeps going on the same thing over here if I just keep drawing it like so. And so on and so forth. But you get the idea. So now when we draw this, if you just to kind of make it easier for you, right, every maximum point right here is going to have this graph go like this. Now, again, remember, because we have to have 2 sections, that's where this comes in handy. Is I got to cut it in half because I'm going to need another asymptote right through here because I'm going to have this one. And then when I graph, now I'm going to have the squeeze one in here as well. That's going to be positioned right there. Okay, so I have another one positioned here, and I'll have this one positioned down here, and then there'll be another one that's positioned here. So you're kind of working off the maximum and minimums, but understanding that there's going to be another asymptote that's kind of built in right through there and right through here. So a little bit messy way. We can clean that up as we go. Okay. All right. Finally, the last thing. We are going to write an equation with a secant function with a period of 3 pi, the phase shift of pi over 2, and the vertical shift. So they don't give us any information here. All they give us is that A, or for an amplitude, so I know my A is equal to 1. They didn't give it to us, so I'm just going to give that to you there. And they give us a vertical shift of 3, so D is equal to 3. I know that. Now I got to find my B and my C. So my period, again, was 2 pi for these ones over B. So my period in this case, they told me was 3 pi. So it's 3 pi equals 2 pi over B. So that I can solve for that. So it's going to save you the time. B ends up being 2/3. Okay, so that helps us there. And then over here for my phase shift, remember to find phase shift, it's negative C over absolute value of B. But they give me the phase shift as pi over 2. So basically pi over 2 equals negative C over my B value, which I just found right here, is 2/3. And then, doing the solving here, I'll let you guys solve that, but you end up getting negative pi over 3. This is my C value. So now I can plug in the equation in secant form, y equals plus or minus. My amplitude is 1, and we're talking secant. So secant, my B value is 2/3. Then my X, my phase shift is the opposite of C, so minus pi over 3, and my vertical shift is 3. Whew, lots to get through there. That was a long one. I told you to buckle up. Hopefully you did, and we'll try to work on this next time I see you. Yeah.